Next topic is the carbides. So here we take any metal oxide. For example, here we take the calcium oxide. It is a metal oxide. This metal oxide is treated with carbon. It is treated with carbon. Here it forms the and carbon monoxide gas. Okay, here it is the carbide molecule. Okay, in these carbide molecules, it is can be classified into three types, in which one is the ionic carbides. Next one is the covalent carbides, and next one is the interstitial carbides. Okay, these carbides can be classified into three types. One is the ionic carbides, second one is the covalent carbides, and next one is the interstitial carbides. So now first we see the ionic carbides. So here ionic carbides are formed. The carbon, it is with more electronegativity atoms, means here the formation takes place in between the more electronegative metals, that is known as a ionic carbides. So here these ionic carbides are again three types. Okay, it is based on the product. These ionic carbides are again three types, in which one is the methanoids. So methanoids means here the product is the methane. Okay, here it forms the methane as a product. So then it is known as a methanoids. So here we see one example, that is Be2 react with beryllium carbide, react with water molecule. Here it forms the CH4 molecule and also beryllium hydroxide. Okay, CH4 is the methane. So here formation of methane takes place. So then it is known as a methanoids. And second one is the acetylides, means formation of the acetylene, that is the C2H2. So here example is calcium carbide with two water molecules. Here it forms the C2H2 and also calcium hydroxide. Okay, here C2H2 is the acetylene. Okay, the formation of acetylene is known as a acetylides. And next one is the formation of the allylides. So allylides means here it is the C3H4 molecule is known as a allylides. So here magnesium carbide react with water molecule. It forms the double bond C, double bond CH. It is the allyl group. So formation of the allyl is known as a allylides, and the remaining is the MgOH2. So here ionic carbides. How to form the ionic carbides? It is formed in between the carbon with highly electronegative atoms. Okay. So here generally these ionic carbides shows the first A and second year group elements, and also sometimes third year group elements also, except beryllium. Remaining element they shows the ionic carbides. So here these ionic carbides based on the product, this can be again classified into three types. One is the methanoids, acetylides and allylides. Methanoids means here the formation of methane takes place, and next one acetylides, here formation of acetylene, and allylides, here it forms the allyl group. Okay, it is about the ionic solids. Next we see the covalent carbides. Generally, these covalent carbides are formed in between the atoms. These are with similar electronegativity. Okay. So, here generally in between similar electronegativity atoms, it shows the covalent carbides. So, here the best example is the silicon. Okay. That is the silicon carbide. It react with oxygen, forms a silicon oxide. Okay. It is the example of the covalent carbide. And last one is the interstitial. Okay. So, interstitial means here we know the here involves the transition elements. So, here the transition compounds like zirconium, vanadium, palladium, molybdenum, all these any transition elements in that crystal, it occupies one small position in that crystal. So, that is known as a interstitial position. Okay. So, interstitial carbides means here that interstitial means here the carbon, it occupies the small amount of the carbon, it occupies that interstitial position in the transition elements. It is known as a interstitial carbides. Okay, clear? We see the three types. One is the ionic, covalent and interstitial. Okay. So, ionic means here that any carbon it forms. Okay. So, example is the calcium carbide and covalent carbides. Covalent carbides, the best example is the silicon. Okay. Why? Because silicon molecule, it shows the covalent bonds. Okay. That's why here we take the example of that covalent carbide is the silicon. So, silicon oxide, it react with carbon, it forms the silicon carbide. And next one is the interstitial. Interstitial means the small amount of carbon, it occupies the interstitial position in the transition elements, that is known as a interstitial carbides. So, here we see the some applications of the silicon. Okay, applications of silicon. Applications of silicon. Generally, silicons, these are used in industrial purpose when it is used in electronic. Okay. So, electronic means here these silicons are used in semiconductors, chips and also solar panels and etc. And next, it is also used in that construction purpose. Okay, in the construction purpose, it is used as a silicon glasses, and also that concrete seals are also prepared by using that silicon. And also here this silicon, it is used in the preparation of the polymers. Okay, polymers means here it is prepared the silicon polymers. Okay, silicon polymers are prepared by using the silicon, and also it is used in the metallurgy process. In that metallurgy process, aluminum or iron, okay, that both are with silicon. So, at that time here that metallurgy process takes place with the help of the silicon. And also here these silicons are used in the cosmetics, hair dryers and etc. These are the applications or industrial applications of the silicon. Next, we see the classification. It is the fourth group element. Now, fourth group elements means it is the carbon family. Okay. So, carbon family in which it shows the classification, especially it is a carbon means organic compound. Okay. So, here this compound with carbon, it can be classified into two types. Okay, in which one is the open chain, and next one is the closed chain. So, here open chain, it again classified into two types, in which one is the saturated compounds and another one is the unsaturated. Means here single bonded compounds like alkanes is known as a saturated. Unsaturated means here double and triple bonded compounds. Okay, means alkenes and alkanes are considered as a unsaturated compounds. Okay, it is about the open chain. So what is the difference between the open chain and closed chain? How to identify it is the open chain and it is a closed chain? Open chain means here it is with the terminal. For example, we take this pen. Okay, here it is with the end. End means it is known as the terminal. So closed chain means there is no any terminal. So it is completely in that closed system, that is known as a closed chain. So this closed chain is again classified into two types. Okay, in which one is the homonuclear and another one is the heteronuclear. Okay, one is the homonuclear and next one is the heteronuclear. So homo means here the molecule, it is with the same type of atoms or elements are present, it is known as a homo. Hetero means here it is with two different atoms or elements are present, it is known as a hetero. So here in this cyclic system, for example, here we take the one cyclic system. Okay, in this cyclic system here it is with carbon and hydrogen and also here it is with any other element. Okay, oxygen is the other element is there, so then it is known as a hetero. Okay, so in this molecule generally it is with carbon and hydrogen. So in that ring here it is with any other elements, means that is the inorganic elements like oxygen, nitrogen, sulfur. Okay, like these elements are present in the ring, that is known as a heterocyclic. Okay, see here all these are the CH. Okay, so see here it is with in this ring. Okay, this ring it is with carbon and hydrogen. Carbon and hydrogen is common, but also in that ring it is with oxygen is there, means here it is the other element is there, so then it is known as a hetero molecules. Okay, hetero molecule means other element it is present within a ring. Okay, then only it is considered as a hetero molecule. So otherwise if you see one example. Here other element oxygen is there, but that oxygen is not inside the ring, it is outside the ring. So outside the ring it is not considered. So for example, here we take this one. Here also it is with nitrogen. Okay, nitrogen is also other element. So but here it is not inside the ring. Okay, it is outside the ring. So it is not considered as a hetero molecule. Otherwise here that nitrogen is present in the ring, then it is considered as a hetero molecule. Okay, once you observe these two differences. Okay, here this nitrogen is outside the ring and here this nitrogen is inside the ring. So inside the ring is considered as a hetero, otherwise it is considered as a homo. And next we go to the homo molecule. This homo molecule is again classified into two types. One is the allylic and another one is the aromatic. One is the allylic compounds and another one is the aromatic compound. So aromatic compound means here it is with the benzene ring and also here it obeys the 4n plus 2 rule, means that is the Huckel's rule, that is known as the aromatic compounds. And allylic here it is again classified into two types. One is the benzenoid compounds and another one is the non-benzenoid compounds. Means that homocyclic compound in which it shows the benzene ring. Okay, benzene ring means it is a benzene ring. Okay, in that ring system here it is with benzene ring, that compounds are known as a benzenoid compound. There is no any benzene ring, these are known as a non-benzenoid compound. For example, see here, it is not a benzene ring now, so it is a non-benzenoid compound. Okay, here it is with the benzene ring now, it is the benzenoid compound. Okay, it is the classification. So in this classification another part is the cross-linked classification. Okay, in this cross-linked, here number of molecules, these number of linear molecules are connected with the branch means finally here it forms one network, one gauge like structure that is known as a cross linked, means here in which the linear structures are with number of branches, that is known as a cross linked. So generally it is in a 3D dimensional shape. So here it is rigid shape, it is with very hard substance. Okay, here this type of bonds are present in that compound. It is very hard, very rigid, means here its melting points is also high. Okay, here example is bakelite and rubber. It is the example of that cross linked polymers or cross linked molecules. So here we see the bakelite. So bakelite it is with the in this bakelite it is with benzene rings, and also here it is with the OH groups, means phenols are participated, and the two benzene rings are connected with the CH2 group. It is a polymer. Okay, here these two are connected with CH2 group. All benzene rings are connected with the CH2 group. Number of that linear molecules are linked with branches. Okay, one branch is connected to the another branch. Finally, here it forms one network or gauge like structure. So that is known as a cross-linked structure. Okay, so due to this cross-linking here, that molecule they shows very hard. That's why here its melting points is also more. It is about the classification. Okay, carbides it is completed. Next we go to the nitrides. Okay, nitrates means these are comes under the nitrogen family, that is the 50 group elements. So this nitrates also classified into three types. So it is similar to that carbides only. Here one is the ionic nitrates. Second one is the covalent nitrides. And last one is the interstitial nitrates. So here ionic nitrates, okay, here ionic nitrates means the bond these are formed, it is due to the more electronegativity or more electropositivity of the element, that is known as a ionic nitrates. So in which generally first A and second A group elements are participating, means alkali and alkaline earth metals are participating in this ionic nitrates. And next one is the covalent nitrates. So covalent nitrates means here in which third A, fourth A and fifth A group elements are ready to form the covalent nitrates. So these covalent nitrates they form that work like structure, and here these are acts as a electric conductors. Okay, and next one is the interstitial. So interstitial means here in which also in the transition elements here the nitrogen it occupies one small position, so that is known as a interstitial. Okay, nitrates are also classified into three types: ionic nitrates, covalent nitrates and interstitial nitrates. Okay, in this nitrates here we see the important topic, that is the nitrogen compound, that is the first one is the N2H4 molecule. So N2H4 is known as a hydrazine. So here how to form the hydrazine? Generally ammonia react with hydrogen peroxide. Here it forms the hydrazine, and also here it forms the water molecule. Okay, it is a preparation of the hydrazine. So here this hydrazine it shows the reactions, that is the one is the decomposition reaction. Decomposition reaction. So what is mean of the decomposition? Decomposition means here large molecule is converted to small molecule is known as a decomposition. So here we take that hydrazine, that is the N2H4 molecule. Okay, here it undergoes the decomposition. Then here it forms the N2 and H2 molecules. Okay, it is known as a decomposition. And next one is the combustion. What is mean of the combustion? Combustion means the reactions are takes place in the presence of oxygen is known as a combustion reactions. Okay, combustion means the reactions that takes place in the presence of the oxygen. This hydrazine, it undergoes the reaction with oxygen. Then here it forms the N2 and H2O molecules. Okay, this hydrazine, it undergoes the decomposition reactions and combustion reactions. Okay, decomposition means large molecule is converted to small molecule, it is decomposed. So on decomposition, this hydrazine, it forms the N2 and H2 molecules. And combustion reactions means the reactions that takes place in the presence of the oxygen. So at that time here it forms a nitrogen and water molecule. Okay, it is about the hydrazine. Okay, so hydrazine formula is the N2H4. So second one is the hydroxylamine. Second one is the hydroxylamine. So hydroxylamine formula is NH2OH. Okay, NH2OH is known as a hydroxylamine. So this hydroxylamine, generally its reactivity is the hydroxylamine. Here aldehydes. CHO means these are the aldehydes. And C double bond O group means these are the ketones. These aldehydes or ketones, they react with hydroxylamine, that is the NH2OH. Here it reacts with aldehydes, it forms the aldoximes. And otherwise this hydroxylamine is react with ketone, it forms the ketoximes. Okay, aldehydes react with hydroxylamine, it forms the aldoxamines, and it react with ketones, it forms the ketoximes. So here see the one example, we take aldehyde. Okay, it reacts with hydroxylamine. So then here it forms the it is known as a aldoxane. Okay, aldehydes react with hydroxylamine, it forms the aldoxane. Otherwise ketones are react with hydroxylamine, it forms the ketoxanes. So last compound, that is the phosphazenes. Okay, in the nitrogen compounds, last one is the phosphazenes. So phosphazenes means here in this type of the compound, it is with organic and also inorganic compounds. Okay, here phosphazenes means here it is with organic and inorganic elements are present. That is known as a phosphazenes. Okay, main the composition it is with the inorganic compounds. Okay, inorganic compounds of the nitrogen and phosphor. So in which here it is with alkyl groups, means that is the organic compound, that is known as a phosphazenes. So generally these phosphazenes, these are available in cyclic form and linear form. If you see the cyclic form, It is the cyclic form. And next we see the acyclic form also. Okay, these two are known as a phosphazines. Okay, so in which it is in the six member ring. Okay, see here, in which here in this molecule nitrogen and phosphorus, these are the inorganic elements. So these inorganic elements, these are in alternatively. Okay, these are present in alternatively, and also in this ring system it is with alternative double bond. Okay, here the double bonds are present in alternatively, means simply here it is in the conjugated system. Okay, conjugated system means double bonds are present in alternatively is known as a conjugated system. Okay, here that R means it is the alkyl group. So here these alkyl groups are also attached to the phosphor. So means here we see the inorganic elements of nitrogen and phosphor, and also it is with the organic element of the alkyl groups are there. So here it is known as a phosphazines. So here it is with the nitrogen and phosphor. So nitrogen it is the trivalency and dicoordinate, and phosphor it is with the pentavalency and tetra coordinate. Okay, clear? In this phosphazines, it is with the inorganic elements of nitrogen and phosphor, and also it is with the organic compound of the alkyls. So the nitrogen and phosphorus are present alternatively with alternative double bonds. In these structures here, nitrogen it is with the trivalent and it is with dicoordinate, and phosphor it is with the pentavalent and tetra coordinate. It is about the phosphazine.